So which of the following solvents is going to favor an SN1 reaction? And remember, substitution, nucleophilic, unimolecular, right? Now this is a bit of a tricky question. So what you need to remember is that SN1 reactions, okay, favor polar protic solvents, whereas SN2 reactions favor polar aprotic solvents. So what does that mean, right? A polar protic solvent is something that is, well, polar, but then it can also donate hydrogen bonds, okay? Whereas a polar aprotic solvent is something that's polar, but it can't donate hydrogen bonds. So which of these answer choices is the only one that can donate a hydrogen bond? Now, DMSO is a tough one because, I mean, we probably don't really know what DMSO looks like, but this is not actually correct. DMSO actually favors SN2 reactions because DMSO is a polar aprotic solvent, polar aprotic. More so conceptually, polar protic versus polar aprotic. Now, the only one here, right, that can actually donate hydrogen bonds, right, is water. Okay, so this is the only polar protic solvent here, technically. Acetone, which looks, I believe, like this, okay, and then diethyl ether, which looks like this, okay, they can't donate hydrogen bonds, okay? Now, the issue with SN2 reactions is that you're using a nucleophile, a strong nucleophile, that needs to get to a substrate that tends to be, first of all, pretty small, generally speaking, right? And the issue is that if you have hydrogen bonding capacity, so like if the solvent, like water is being used as a solvent, and it can donate hydrogen bonds, okay, then that can actually overly stabilize the nucleophile, right? And then the nucleophile might never actually physically reach the electrophile or the substrate, okay? It might be too stable to actually react, which would not really allow for that reaction to occur.